Hello everyone and welcome back. I hope you had a great test. It seems quite decent to me. FRQ-1 is exactly how we expected it to be. It has everything quite similar to the paper last year. So I'll give my solutions right here. And if I'm wrong anywhere, please let me know. I'll fix it as soon as possible because at the end of the day, I too am not a genius. So yeah, let's move ahead. Okay. Um, Number one, the function f is decreasing and is defined for all real numbers. The table gives values for f of x at selected values. We have a table here. The function g is given by g of x is equal to some cubic polynomial, and we're given the following. The function h is defined by h of x is equal to g composed with f of x. Find the value of h of 1 as a decimal approximation or indicate that it is not defined. Show the work that leads to your answer. So, we are supposed to find h of 1 and we're given that h of x is equal to g of f of x. Now if you're not sure about function composition, I recommend you check out any video where they will explain you what a function composition essentially is. So it's like you take the input of g to be the output of f. That is how simple it is. So if we're supposed to evaluate h of 1, we have g of f of 1. Now first start by evaluating f of 1. We know that f of 1 from here is 1.75. So I take f of 1 to be equal to 1.75. And now what's left to evaluate for h of 1 is g of the output of f of 1, which is 1.75. And remember, this is the calculator active section, so do not sit to evaluate this whatsoever. Quickly take out your calculator and put in the value. And I'm getting h of 1 as 0.33, 0.33. I have three threes and then I have a 4. I think they will accept this, whether it's a decimal or to right or left, it doesn't matter. Now the second part is find the value of f inverse of 3.5 or indicate that it is not defined. Now, one thing about function inversion is that if you have a set of inputs x and if you have a set of outputs y, then the function f takes the inputs to the outputs. This is function f. But the inverse function of f, which is f prime of x, essentially takes the outputs to the inputs. This is f inverse of x. So when they ask us to find f inverse, so f inverse of 3.5 would mean which x value corresponds to the y value 3.5. And looking at the table, we have this one. So f inverse of 3.5 should be 0 because f of 0 is 3.5. So f inverse of 3.5 is 0. I hope that part A was very clear. Okay, part B. Find all values of x as decimal approximations for which g of x is 0 or indicate that there are no such values. So over here, they are asking you to find the zeros of the function g of x, which is quite simple. You could take your graphing calculator, graph the function g of x, and get your zeros. But I'll teach you how are you supposed to solve a general case. Because when you're finding the zeros, you could take the calculate zero function, calculate zero function, and that will give you the zeros which are right here. I've given the values here if you want to refer to them. But what if instead of g of x as 0, I said find all values of x for which g of x is equal to 3. G of x is equal to 3. How would you approach this? Well, it's quite simple. Just take the y1, which is the first graph, as g of x, and take a second graph, y2, as 3. And you'll have a line right here. You'll have a horizontal line right here at y equal to 3. And that will give you the output values, the input values for g of x being equal to 3. So it has, again, it has nothing to do with this particular FRQ, but I'm letting you know that if instead of g of x is equal to 0, you were asked to find g of x is equal to 3. I hope that was clear. Moving on to subpart 2. Determine the end behavior of g as x increases without bound. Express your answer using the mathematical notation of a limit. Now, clearly, when you look at the graph, you'll see that as x goes to positive infinity, your y value goes to negative infinity. So what I'll write is that the limit as x approaches positive infinity of g of x equals negative infinity. Now, I think you might also need to write the sentence that as the end behavior of g as x increases without bound is the following. I think you need that maybe, but if you won't, I don't think they'll cut your marks because they've just mentioned express your answer using mathematical notation of a limit. So I think that should be fine either ways. Moving on to the final part, which is part C. Based on the table, which of the following function types best models function f? Linear, quadratic, exponential, or logarithmic? Now, if you notice the input values, they're actually equally spaced, right? -2, -1, -1, 0, 0, 1, and 1, 2. Many a times you might not have equally spaced input values, and you need to be aware of them. But over here we have equally spaced, so there's no need to worry about that. And if you look at the outputs, 14 divided by 2 is 7. 7 divided by 2 is 3.5. 3.5 divided by 2 is 1.75, and 1.75 divided by 2 should be 0.875, which means there's a constant factor of multiplying by 0.5. And whenever you notice proportionality where the outputs are proportional to each other by a constant proportional factor, then it will always be an exponential function. So based on the table, an exponential function, uh, best model function f. Now part 2 is give a reason for an answer in part C based on the relationship between the change in the output values of f and the change in the input values of f. So they want us to implicitly mention both input values and output values. So we'll say that output values change proportionally over input values that are equally spaced. So exponential is the best choice. Now, I'll let you know one thing. I'm not sure about this answer, okay? I have no idea whether this answer would earn full credit or not, but I know that it will be modeled something around this part. So don't trust me on this part, but yeah, you can take this as a reference to whether your answer would be correct or incorrect. And that ends my part FRQ1. I hope you enjoyed it. Thank you.